Imagine you're standing at the edge of the world, not the edge of a cliff, but the edge of a map of our own planet. Below you, the familiar continents and coastlines are rendered in sharp, intricate detail. But as your gaze drifts out over the blue, the detail abruptly stops. The land beneath the waves fades into a vast, featureless void. This is where our knowledge runs out. This is where the story of the deep begins. We live our lives under an open sky. On a surface, we've charted, measured, and photographed down to the last square meter. We know the peaks of our highest mountains and the paths of our driest deserts. Yet, beneath the shimmering surface of the sea, lies a domain larger than all the continents combined. A world of which we have seen less than 20%. 80% of our own planet's foundation remains a mystery, hidden under miles of water, shrouded in absolute darkness, and crushed by unimaginable pressure. Down there, mountain ranges dwarf the Himalayas, and canyons carve wounds deeper than the Grand Canyon. Abyssal plains stretch out like serene, silent deserts, and trenches plunge to depths so profound that Mount Everest could be placed within them without breaking the surface. This fear of the unknown is not new. For centuries, our ancestors populated these blank spaces on their maps with imagination. They drew krakens with city-sized tentacles and leviathans with jaws that could swallow ships whole. Sea monsters were the placeholders for their ignorance. Today, our monsters have retreated, but the blankness remains. It has simply sunk from the surface of the map to the floor of the sea itself. We've replaced serpentine beasts with the cold, hard data of Unexplored. But the void is still there, a silent challenge to our perception of a fully discovered world. And knowing what lies in that void has never been more critical. The seafloor is not just a passive basin of mud and rock. It is a dynamic, living system that dictates the health of our planet. It governs our climate, acting as the world's largest carbon sink, locking away greenhouse gases for millennia. Hidden volcanic ridges shape the chemistry of the oceans, while unseen fault lines can trigger earthquakes and tsunamis that devastate coastal communities with little warning. It's a repository of history, holding lost shipwrecks and submerged ancient landscapes that whisper tales of our own past. And it's a cradle for life, where ecosystems thrive in total darkness, evolving in ways we are only just beginning to comprehend. Think of the first human who ever wondered about the depth. They stood at the water's edge, holding a simple stone tied to a rope. They tossed it in, feeling the line pay out, counting the hand-over-hand pools until it returned, wet and cold. It was the first question asked of the deep. How far down does it go? From that simple, primal act of measurement, we jump forward thousands of years. Now, we stand on the deck of a modern research vessel, the air humming with the quiet power of technology. Beneath our feet, a multibeam echosounder sends not a single stone, but a wide fan of acoustic energy into the abyss. It doesn't just ask how deep, but what shape. Wheat. Each ping, a sliver of the unknown, is illuminated. A strip of darkness is painted with data, revealing a ridge, a valley, a plume of gas rising from a hydrothermal vent. The ocean floor is our planet's memory vault, a geological library holding the origin stories of continents, the final resting places of forgotten voyages, and the blueprints for life forms so alien they might as well be from another world. In the profound, crushing quiet, where the only light is the fleeting spark of bioluminescence drifting past like distant stars, the Earth keeps its oldest secrets. And as the sonar pings once more, that single pulse widens, blossoming into a vibrant fan of color on a screen, and a new piece of the map begins to glow. The hiss of rope uncoiling across a damp, wooden deck is the only sound, besides the creak of the ship and the distant call of a seabird. Yard by yard, the lead line disappears into the gray water, a simple weight at its end, its bottom coated in sticky tallow. For centuries, this was our only way to ask the ocean its most basic question. How deep are you? When the line finally slackens, we haul it back up, and over-end muscles straining. At the end, pressed into the tallow, is our answer. A few grains of sand, a fragment of shell, a tiny, tactile message from a world we could only imagine. This single touch was the beginning of our quest to truly see the abyss. Before this, the deep was a realm of pure imagination. For the ancient Greeks, it was the bottomless, unknowable sea described by Homer. For Polynesian wayfinders, it was a living map of swells and currents, read with a body, not a chart. On medieval maps, the ocean floor was where imagination ran wild, a flat, featureless plain populated by krokens and sea serpents, where the blank spaces were simply labeled, "Here be dragons." These weren't maps of the world as it was, but of our fears and our wonders. They were beautiful, but they told us more about ourselves than about the 70% of our planet hidden beneath the waves. The shift from myth to measurement was slow, painstaking, a gradual turning toward the empirical. We were learning to replace wonder with a different kind of awe. The awe of discovery. That new era truly began with the HMS Challenger. In the 1870s, this repurposed warship set out on a 4-year mission, not to conquer, but to understand. The rhythmic clank and splash of its dredges replaced the simple hiss of the lead line. These heavy iron nets scraped the seabed, bringing up mud, rock, and creatures never before seen by human eyes. Thermometers encased in special pressure-proof housings were lowered into the crushing dark to take the temperature of the abyss. For the first time, a scientific portrait of the deep began to emerge. The official narrative of the expedition soberly states, "The dredge and trawl, with their various modifications, are our most important instruments for investigating the bottom of the sea and its inhabitants." A simple sentence, but it marked a revolution. The seafloor wasn't a void. It was a complex, varied, and inhabited world. The dragons were gone, but in their place, a new and stranger reality was taking shape. That reality found its artist in Marie Tharp. In the mid-20th century, working in a New York studio, she took scrolls of data from naval echo sounders' endless streams of pings, and the returns hand began to draw. With the patient rasp of a pencil on paper, she translated those cold numbers into landscapes. Slowly, a breathtaking picture emerged. Not a flat plain, but a world of immense mountain ranges. Chasms deeper than any on land, and a colossal seam running down the middle of the Atlantic. This was the Mid-Ocean Ridge. Her hand-drawn maps, elegant and precise, were the first to reveal the planet's hidden skeleton. She saw the rift valleys tearing the continents apart. And in doing so, gave us the first visual proof of plate tectonics. She was mapping the engine of our world, one pencil stroke at a time. Meanwhile, the Cold War turned the ocean into a theater of secrets. In the hunt for enemy submarines, acousticians discovered something extraordinary. The SOFAR channel, or the deep sound channel, at a certain depth, temperature and pressure, conspired to create a corridor where sound can travel for thousands of miles with little loss of signal. A whisperer in the Atlantic could, theoretically, be heard in the Indian Ocean. This acousto-whisper gallery was exploited for military listening, but it also gave us an entirely new sense. Hydrophones, dangling in this channel, picked up not just propellers, but the distant, mournful songs of whales, the groans of shifting tectonic plates, and the low rumble of undersea volcanoes. We were learning to listen to the planet's pulse. But to truly know the deep, we had to go there. First came the hesitant drops of the bathysphere in the 1930s. A tethered steel ball where 2 men peered out a tiny quartz window, their own breath fogging the glass against the immense pressure. Then, in 1960, the untethered bathyscaphe Trieste made the ultimate descent. It touched down in the Challenger Deep, the lowest point on Earth, nearly 7 miles down. The pressure outside was over 1,000 times that at the surface, enough to crush steel. Inside, 2 men sat in a tiny sphere, listening to the creaks and groans of their vessel, floating in a world of absolute black, illuminated only by their own small beams of light. They had done it. Humanity had finally set foot, figuratively, in the deepest, most alien part of our own world. From these first human glimpses, our eyes have become robotic, our senses extending through fiber-optic cables. We no longer just map the mountains and valleys. We explore them. Our robotic submersibles now glide along the crests of those very ridges. Marie Tharp first drew, and as we move along a newly charted ridge, the sonar gives way to a camera's view. Up ahead, shimmering in the lights, a plume of black smoke billows from the seafloor. It's not smoke, but a hydrothermal vent, spewing superheated mineral-rich water from the planet's core. And all around it, in the crushing dark, life thrives not on sunlight, but on chemistry. We have arrived in a new world, a place we once thought was a void, only to find it teeming with a different kind of creation. The year is 1977. We are 2.5 kilometers beneath the waves, suspended in a silent, endless black. Outside the viewport of the submersible Alvin asterisk, the only universe that exists is the one carved out by our powerful lights. We are drifting over the Galapagos Rift, a place no human has ever laid eyes on before. The water is cold, the pressure immense. The beam cuts through the dark, and then something impossible appears. Towers, jagged black chimneys billowing what looks like smoke into the water. We are witnessing a black smoker, a hydrothermal vent, for the very first time. The water around it shimmers with heat, a stark contrast to the near-freezing abyss. But it's not the geology that steals the breath. It's the life. Clustered around these volcanic outlets is an entire ecosystem, a riot of impossible creatures thriving in total darkness. Giant tube worms, some taller than a person, stand in dense thickets. Their bodies are encased in white, chitinous tubes. But from the top, brilliant red plumes unfurl like alien flowers, pulsing softly in the current. They have no mouth, no gut, no anus. They are utterly alien. Around their bases are beds of enormous white clams, their shells stained with minerals, packed together so tightly they form a living pavement. Ghostly white crabs scuttle over the rocks, their eyes long since lost to evolution. This is not a barren desert. It's a bustling city, powered by a fire within the earth. How can this be? Down here, there is no sunlight, no photosynthesis, the engine that drives nearly all life on the surface. The answer is a different kind of magic, a process called chemosynthesis. Instead of sunlight, the foundation of this food web is built on chemicals. The smoke billowing from the vents isn't smoke at all. It's superheated, mineral-rich water, saturated with compounds like hydrogen sulfide, poison to most life on Earth. But for the microbes here, it is a feast. These ancient bacteria are the true masters of the deep. They harness the chemical energy from the vents to create organic matter. The tube worms, the clams, the mussels they don't eat in the traditional sense. Instead, they host these chemical-loving microbes within their bodies in a perfect symbiosis. The animals provide shelter and deliver the chemicals from the vent fluid. And in return, the bacteria produce all the food they need to survive. It's an entirely separate tree of life, one that whispers of how the first organisms on our own planet might have begun in the dark, hot cradle of the early oceans. It also gives us hope that life might exist elsewhere in our solar system, perhaps in the dark oceans, hidden beneath the icy shells of moons like Europa or Enceladus, warmed by their own internal heat. For decades, we thought all vents were like these black smokers, hot, acidic, and rich in Then, in the year 2000, we found something else. Something even stranger. Drifting over a deep-sea mountain in the mid-Atlantic, scientists discovered a forest of ghostly white spires, some reaching 60 meters high. This was the Lost City. Instead of black, sulfurous smoke, these chimneys exhale a warm, clear, alkaline fluid, shimmering with a ghostly blue hue. The towers are not volcanic rock, but carbonate, similar to limestone, slowly building up over tens of thousands of years. And here, a different kind of microbial community thrives, using a completely different recipe for life. They feed on methane and hydrogen, produced not by volcanic heat, but by a chemical reaction between seawater and the mantle rock below. The Lost City proved that there wasn't just one way to build an ecosystem in the dark. There were at least two. Finding these oases is a monumental challenge. The ocean floor is a vast, unmapped wilderness. A vent field might only be a few hundred meters across, a needle in a continent-sized haystack. We start with broad strokes, using ship-based sonar to create low-resolution maps of the sea, looking for signs of recent volcanic activity. Then we get closer, deploying autonomous underwater vehicles that use multibeam bathymetry to paint a more detailed picture, looking for unusual textures or spikes that might signal a chimney, We scan the water for temperature anomalies or chemical plumes that could lead us back to the source. The final confirmation comes from sight, the shimmering signature of hot water mixing with cold, a telltale glimmer in the sonar that says something is alive down there. Down here, inside Astris, Alvin Astris, the world is muffled. The hum of the thrusters is a constant, low hush. Outside, there's a soft crackle, the sound of superheated, mineral-laden water crystallizing as it hits the cold sea. Every now and then, a faint, percussive pop echoes through the hull as a piece of a chimney gives way. The red plumes of the tube worms sway in a silent dance. We've seen a world we never knew existed, a world that rewrites the rules of life. Now, it's time to leave. The thrusters engage, and we begin to drift upward, rising through the shimmering plume. The sounds of the vent field fade. The towers recede into the gloom. The seafloor below us falls away, disappearing into an even deeper, steeper contour. We are leaving the rift and approaching the edge of a trench, where the darkness is older and the secrets are buried even deeper. Sound of a single, clear sonar ping, echoing and fading. It begins with a single word, spoken into the darkness. A ping. It spreads not like light, but like a ripple in a silent pond. A halo of sound expanding through the immense, pressurized black. This is how we see where light cannot go. This is how we map the abyss. In the early days, it was one pulse at a time. A single beam sent straight down, listening for the echo. Ping ... Wait ... Pung. The time it took told us the depth. It was like feeling your way through a dark room with a long cane, tapping the floor with each step. Slow, methodical. But it gave us our first, crude sketches of the world beneath the waves. Now, we speak in paragraphs, not single words. We use multibeam sonar. Imagine not a single cane, but a wide fan of them, hundreds of them, sweeping the seafloor in a broad swath. With every ping, we send out a fan of sound, and we listen as a chorus of echoes returns. Each echo tells us two things. First, its travel time gives us depth, painting a three-dimensional picture of mountains and valleys. Second, its intensity, its loudness, tells us about the texture of the bottom. A loud, sharp echo screams of hard rock. A soft, muffled return whispers of thick mud. This is called backscatter. It's the difference between seeing a hill and knowing if it's made of stone or sand. We are painting the seafloor, stroke by stroke, swath by swath. But even this has its limits. From the surface, miles above, the details blur. To truly see the fine print, to read the seafloor story, we have to get closer. We send down our scouts, autonomous underwater vehicles, or AUVs. These torpedo-shaped robots glide silently, just meters above the seabed, like birds soaring over a hidden landscape. Their sonar is inches from the target, capturing details in stunning resolution. We can also send down remotely operated vehicles, or ROVs, tethered to the ship. We fly them with joysticks, their cameras and lasers stitching together photographic mosaics, revealing the texture of a lava flow or the tracks of a strange creature. It's a delicate art, this deep-ocean flight, navigating unseen currents in jagged terrain, all to bring the abyss into focus. You might wonder, can't satellites do this? Don't they map the whole planet? Yes, but they map with a different sense. A satellite can't see the seafloor, but it can feel its gravity. A massive undersea mountain, a seamount, has more mass, so it pulls the water towards it, creating a subtle, permanent bulge on the ocean's surface. A deep trench does the opposite, creating a slight depression. Satellite altimetry measures these tiny hills and valleys on the sea surface and infers the topography below. It's an incredible feat, but it's like reading a book through a foggy window. It gives us the broad strokes, the major mountain ranges, and the deepest trenches. But the fine details, the canyons, the ridges, the life that's all lost in the blur. That's why the ships are still out here, patiently, endlessly, pinging, and the ocean is never truly silent. As we listen for our own echoes, we overhear its conversations. The constant, crackling static isn't noise. It's the sound of millions of snapping shrimp, a sizzling chorus that fills the water. We hear the haunting, melodic songs of whales, traveling for hundreds, even thousands of miles, trapped in a special layer of water called the SO4 channel, where sound waves surf the currents of temperature and pressure. Far off, we feel a low, resonant boom on Ertekwak, shaking the very bones of the planet. Sound bends and warps down here, its path guided by the invisible walls of temperature and pressure, creating strange acoustic shadows and channels of clarity. Our fan of sound continues its sweep, painting the familiar, rolling abyssal plains. The pings are a steady metronome, a heartbeat in the deep. Ping, data streams in. Ping, dot, 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 the map grows. But then, something changes. The echoes from the outer edge of our sonar swath suddenly vanish. They don't return. The sound is being swallowed. On the screen a wall of black appears, a sharp, steep, vertical drop that our fan of sound, Ungled, Asit, is simply shoots past, into an unknown depth. We've reached the edge of a trench. Its lip so severe it consumes our language of echoes. The seafloor has just fallen away, yawning open into the Hadel zone. Listen. Do you hear that? That soft, rhythmic ticking. It's the sound of pressure. The sound of our submersible's hull compressing, molecule by molecule, under a weight that defies imagination. We are descending, past the twilight, past the midnight, into a realm that holds the last true wilderness on our planet. The Hadel zone, 6,000 meters down. Then 7. The water outside is just above freezing. A chilling embrace that seeps through layers of titanium and steel. The pressure here is 1,000 times what it is at the surface. It's a force that would crush bone and metal into powder. Yet life, life finds a way. The sub's lights cut through an eternal night, illuminating a world painted in monochrome. The seafloor isn't solid rock. It's a blanket of fine, pale silt, disturbed by our descent. It rises and drifts, not like mud, but like smoke. A ghostly landscape of soft, billowing clouds. This is the floor of a trench, a scar on the planet's skin where one tectonic plate is forced beneath another. These are the cradles of megathrust earthquakes, the birthplaces of tsunamis that reshape coastlines thousands of miles away. Down here, the Earth's violence is a slow, grinding process, hidden beneath an ocean of silence. Look closer, through the viewport, that delicate, almost translucent creature gracefully gliding by. That's a Hado snailfish. Its body is gelatinous, a marvel of evolutionary engineering, built not to resist the pressure, but to yield to it. Its bones are flexible, its flesh mostly water, allowing the immense force to pass through it harmlessly. They are the deepest living fish ever recorded, phantoms of the abyss. And see those swarms of tiny, shrimp-like organisms hopping across the sediment. Those are amphipods, supergiant in their own world, thriving in conditions that should make life impossible. They are the scavengers of the deep, feasting on the scant marine snow that drifts down from the sunlit world miles above. Modern expeditions, like the groundbreaking Five Deeps project, have sent robotic eyes and even human-piloted craft to these ultimate depths. Their cameras have shown us this fragile ecosystem in stunning detail. But they've shown us something else, too. A quiet, sobering truth. A glint of something unnatural in the siltoplastic fragment. A wrapper, a ghost of our world above, resting here in the deepest, most remote corner of the Earth. A stark reminder that our reach is longer and more invasive than we ever imagined. The hull groans softly, a reminder of the immense forces at play. Fine sediment whispers across the acrylic viewport, a constant, gentle abrasion. Out in the darkness, beyond the cone of our lights, tiny sparks of bioluminescence flash and fade. They are not stars, but living creatures, signaling to each other in a language of light. It's easy to let your mind wander in this place, to see the shapes of ancient myths in the shadows. The Leviathans, the Krakens, were they just sailors, tailies? Or were they a folk memory of the true, unimaginable scale of the deep? Imagination rushes to fill the void where sunlight cannot reach. Wait. What was that? A flicker, a reflection just at the edge of the light. It wasn't the soft glow of a living thing, or the dull sheen of rock. It was sharp, metallic. A glint from a shape that doesn't belong here, resting in the silt where no human hand should have placed it. It's a form, angular and broken, half buried in the abyssal plain. A story, waiting in the dark. The ocean floor is a library of last moments, a quiet archive of journeys that ended too soon. Down here, in the crushing dark, even giants like the Titanic become part of the landscape. For decades, it was a ghost, a legend whispered among sailors. Finding it wasn't a single eureka moment, but the result of drawing long, patient lines across a vast, blank chart. Now, its corroded hull isn't just a memorial, it's a scientific station. The way the currents have sculpted its decay, the way iron-eating microbes have draped it and rusticles these formations, teach us about the deep sea's relentless, creative force. It's a landmark, not just of human tragedy, but of oceanic time. We often think of finding a wreck as an end to a mystery. But for vessels like the USS Johnston, discovered nearly 4 miles down, finding it was just the beginning. It's the deepest war grave ever located. At that depth, retrieval is impossible. To find it is to simply know where it is, to place a single, respectful pin on a map that is mostly empty. It's a confirmation that the ocean keeps its secrets well. We can beseech, we can bear witness with our robotic eyes, but we cannot bring them home. The finding is a solemn nod, an acknowledgement of a final resting place that will remain undisturbed for centuries. Sometimes, the search for one story accidentally uncovers 1,000 others. The massive, multinational effort to find Malaysia Airlines Flight 370 was, at its heart, a hunt for a modern tragedy. But in the process of methodically scanning the seabed, teams mapped enormous, previously unknown regions of the southern Indian Ocean. They were looking for a single ghost, but they found an entire geography of hidden canyons, volcanic cones, and underwater mountain ranges. It has a poignant irony. A search born of loss gave us an unprecedented look at a world we never knew existed. A reminder that every inch of this planet still holds the potential for discovery. Not all underwater history is a story of violent decay. In the Black Sea, there is a place where time has almost stopped. Below a certain depth, the water is anoxic, it holds no oxygen. Here, shipwrecks from the Ottoman and even Byzantine eras lie perfectly preserved. Imagine a Roman trading vessel, its mast still standing, its coiled ropes lying on the deck as if the crew just left them. The wood is not eaten, the carvings are not eroded. The still, silent water has sealed these vessels like time capsules, offering an undisturbed glimpse into a world that vanished from the surface 2,000 years ago. It's not a grave, but a museum, curated by chemistry in depth. The sea holds memories far older than any shipwreck. We now know that vast landscapes, once home to our ancestors, lie drowned beneath the waves. Doga Land, the land bridge that once connected Britain to continental Europe, was a thriving plain of rivers and forests. As the last ice age ended and the seas rose, it was slowly inexorably submerged. Archaeologists now trawl for ancient tools and bones, finding the ghostly footprints of Mesolithic hunters on the seabed. The sea didn't just claim ships, it claimed entire worlds, erasing them from our maps, but archiving them in sediment, waiting for us to learn how to read the story written in the silt and sand. Down here, the world moves differently. What looks like a scrap of cloth fluttering from a railing is actually a delicate colony of bacteria, a living shroud. Every movement of our remote vehicles stirs up a bloom of fine silt, a cloud of dust that hangs in the water like a memory before settling again. There is no sound but the gentle hum of our equipment and the slow, deep pulse of the ocean itself. But as our sonar sweeps past the wreck, it paints a new shape on our screens. Something that isn't made of iron or wood. It's a perfect, geological dome rising from the abyss in uncharted seamount. A mountain that has never seen the sun. It pulls our attention away from the human story of loss, and reminds us that this kingdom belongs, first and foremost, to the earth and the life that thrives in its deepest, darkest corners. The beam of our submersible slices through the perpetual twilight, and slowly, a shape emerges from the darkness. It's not a creature, not a shipwreck. but something far grander. The summit ridge, vast and ancient, rising from the abyssal plain like the spine of some colossal, sleeping giant. We're thousands of feet beneath the waves. Yet we are climbing a mountain without a name. These are the seamounts, underwater volcanoes that have never breached the ocean's surface, and their flat-topped cousins, geos, eroded by ancient waves. They are Earth's most numerous mountain range, yet most remain entirely unexplored, their peaks uncharted and their valleys unseen. For millennia they have stood in silence, but they are anything but lifeless. As we ascend, the featureless slope gives way to a metropolis of life. Seamounts disrupt deep-sea currents, creating eddies and upwellings that stir nutrients up from the depths. This cosmic dance of water feeds an explosion of biodiversity. Here, forests of deep-sea corals, some living for thousands of years, branch out in intricate, fragile lattice of pink, white, and gold. Sponges, shaped like vases and trumpets, filter the water, creating habitats for countless smaller organisms. Swarms of orange ruffy and alphonsino drift like living clouds, their silver scales flickering in our lights. Miniature constellations in this inner space. The water itself hums with a gentle current, punctuated by the soft, crackling static of a million tiny shrimp. It's a city that never sleeps, built on a foundation of ancient stone and fueled by the patient rhythm of the abyss. Modern surveys and deep-diving research vessels are only just beginning to pull back the curtain on these hidden worlds. Recent expeditions have revealed coral reefs towering hundreds of feet high, entire ecosystems that scientists never knew existed. They've mapped features taller than any skyscraper on land, all thriving in the crushing pressure and absolute dark. It's a humbling reminder of how much we still have to learn about our own planet. Drifting past a coral grove, a flicker of movement catches my eye. It's a siphonophore, a colonial organism that looks like a single creature but is actually a chain of specialized individuals, pulsing with a faint, ethereal bioluminescence. It drifts like a string of ghostly pearls, a perfect example of life's surreal ingenuity in this extreme environment. A little further on, an ultra-blackfish, a fangtooth, perhaps absorbs nearly all the light we shine on it, a swimming void in the water column. Its biology isn't sensational. It's a masterclass in deep-sea adaptation, a creature that has perfected the art of not being seen. Bate Venera. In this remote sanctuary, the touch of humanity is visible. We see the scar's first long, parallel gouges cutting through the delicate coral gardens. These are the marks of bottom trawling, fishing nets dragged indiscriminately across the seafloor, destroying ancient habitats that may never recover. The lure of resources is strong. These seamounts are rich in cobalt crusts and polymetallic nodules, valuable minerals for our modern technologies. This brings us to an ethical tightrope. The immense promise of deep-sea mining versus the irreversible destruction it could cause to these unique, barely understood ecosystems. How do we balance our needs with our responsibility to protect these last wild places? Mapping these underwater peaks isn't just for scientific curiosity. For maronas, an uncharted seamount is a catastrophic hazard capable of snagging nets, or worse, ripping the hull of a submarine. For conservationists, knowing where these habitats are is the first step toward protecting them. Each new peak added to the map is a victory for safe navigation and a potential sanctuary for life. Our exploration of the summit is complete. Now, we begin our descent along the mountain's flank. The terrain slopes away into the gloom, but ahead, something shimmers. It looks like a mirage, a trick of the light and pressure. As we get closer, the shimmering distortion resolves into a clear, sharp line. We've reached the shore of a lake within the sea. It's a brine pool, a depression in the seafloor, where super salty, dense water has settled, creating a self-contained alien body of water. The edges are littered with the preserved bodies of creatures that strayed too close and could unhandle the salinity shock. It's a stark, beautiful, and utterly strange landscape. We hang at the edge, peering into a pool of what feels like another world entirely, nested within the deep ocean. We are descending. The lights of our submersible skim across a surface that isn't the seabed. It's something else, a shoreline, thousands of feet beneath the waves. The water here wrinkles, shimmers like disturbed mercury. This is the edge of a brine pool, a lake within the ocean, so dense with salt that it refuses to mix with the water around it. It is a toxic, still world. Live teeters. On its very edge, mussels and tube worms form a living dam. A stark boundary between two realities. Crabs and fish venture close, drawn by the bounty. But one wrong move, one dip into the heavy, anoxic brine, and they become pickled monuments to their curiosity. The stillness is absolute, a silent testament to chemistry's power to draw lines and create forbidden zones. From these still lakes, we drift toward a different kind of activity, a place where the seafloor breathes. These are cold seeps, where methane, long trapped beneath the sediment, bubbles up from the depths. It's like watching soda fizz from the earth itself. The methane meets the cold, high-pressure water and freezes into strange, beautiful structures called methane hydrates or clathrates. They look like ice, but they are flammable fire ice. And around these bubbling chimneys, life has engineered a miracle. Vast beds of mussels blanket the seafloor, thriving not on sunlight, but on a partnership. Microbes, living inside their gills, consume the methane, converting this raw hydrocarbon into energy. It's a city powered by gas, a metropolis built on a chemical handshake between bacteria and a world completely independent of the sunlit surface we know. The seafloor has other secrets, other ways of bleeding the deep geology of our planet. Here, we find asphalt volcanoes, not fire and lava, but a slow, cold ooze of hydrocarbons, the very same stuff we pave our roads with. Tar flowers bloom in the abyssal dark, forming hard, cracked plains and frozen rivers of pitch. It seems like a wasteland, a spill that has been happening for millennia. Yet, even here, life persists. Strange microbes have adapted to consume the asphalt, and other creatures graze upon these microbial films. It's a slow-motion ecosystem, a community that has learned to tolerate and even thrive in an environment that should be utterly hostile. These formations are a direct link to the planet's ancient carbon cycle, a reminder that the building blocks of life and industry are seeping from the Earth's crust in the most unexpected places. The idea of a river underwater isn't just a fantasy or a trick of density. In the flooded cave systems of the Yucatan, a layer of hydrogen sulfide shed from decaying jungle debris settles beneath the fresh water, creating a ghostly, flowing river within the cave. Divers can literally swim above this toxic cloud. And on a much grander scale, entire basins like the Black Sea act as gigantic time capsules. Below a certain depth, the water is completely devoid of oxygen. Anything that sinks into this dead zone is preserved with incredible fidelity. Ancient shipwrecks, turwood, uneaten by organisms, lie waiting in the dark. Chemistry writes these maps, dictating where life can exist and where time itself seems to stand still. Each layer of sediment, each chemical gradient, is a page in a history book written over eons. All these extreme environments, the brine pools, the methane seep, the asphalt fields are not just deep-sea curiosities. They are critical players in our planet's climate. They are vast reservoirs where carbon is locked away or sometimes released. That bubbling methane is a potent greenhouse gas. Understanding where these seeps are, how stable the hydrates are, is crucial for modeling our future climate. As the oceans warm, could these frozen caches of methane thaw and be released? This is why detailed mapping of the seafloor, this intricate bathymetry, is so important. It helps us understand ocean currents, predict geological hazards like underwater landslides, and track the flow of carbon through the global system. The deep is not disconnected. Its chemistry and geology are intimately tied to the air we breathe. From the edge of a toxic lake, our submersible begins to rise. We ascend past the strange, isolated ecosystems, leaving the bubbling chimneys and tar fields behind. The camera pulls back, revealing the vast, seemingly empty expanse of the abyssal plain. A gentle flurry of marine snow, the faint dust of life from above, settles on a landscape we have only just begun to explore. An immense, dark wilderness, holding secrets we are only now learning to ask questions of. It's latte. Out here, the only lights are the glow from these screens, and the distant stars that the clouds let through. You can hear the rain tapping on the steel deck, a steady rhythm against the quiet hum of the engines. We're moving, slowly, methodically, painting a tiny sliver of the world that no one has ever seen before. And it makes you wonder, why, in an age where we've mapped Mars, is our own planet still so full of blank spaces? The simple answer is scale. The ocean is vast, and mapping it isn't like taking a snapshot from space. Satellites can measure the sea surface, giving us a blurry, low-resolution hint of the mountains and valleys below, but they can't see the details. To truly map the seabed, you need to be here, on a ship like this, sending sound waves down into the dark and listening for the echo. Our most advanced multibeam sonar can only map a swath a few kilometers wide. Now, imagine trying to mow the entire Pacific Ocean, one narrow strip at a time. You're fighting against weather, spending fortunes on fuel, and cycling crews through months-long voyages. It's a monumental, painstaking task, and that's before you even get to the lines drawn on the map by humans. The ocean floor is a patchwork. We have incredibly detailed maps of major shipping lanes and areas where submarine cables are laid, because it's economically vital. But venture away from those corridors, and you fall into vast voids. Nations control their own waters, their exclusive economic zones, and getting permission to map inside them involves navigating a maze of geopolitics and national security concerns. Data is sensitive. A detailed map of your coastline could be a strategic advantage for someone else. So, large parts of the ocean remain blank simply because we're not allowed to look. But there's a quiet revolution underway. It's called Seabed 2030, a massive global collaboration with a single, audacious goal: to map the entire ocean floor by the end of the decade. It's a puzzle being solved by many hands. We're crowdsourcing data, equipping fishing fleets, cargo ships, and even private yachts with simple data loggers that passively collect depth information as they go about their business. Think of it like a global team of citizen scientists, each one contributing a tiny piece of the map, and the technology is evolving at an incredible pace. Fleets of autonomous, uncrewed surface vessels and underwater drones are being deployed, able to work around the clock in places too dangerous or remote for ships like this one. They are the future of exploration. Tireless, efficient, and expanding our vision into the deep. This isn't just about filling in a map for curiosity's sake. Better maps are a form of data ecology, profoundly connected to our survival and the planet's health. With a clearer picture of the seafloor, we can create more accurate tsunami warning systems, potentially saving thousands of lives. We can route internet cables more safely, protecting the digital backbone of our world. And crucially, we can identify and protect fragile, vital ecosystems, deep-sea coral gardens, and unique hydrothermal vent communities that we are only just beginning to understand. It brings a profound ethical question to the surface. Knowing where these places are is the first step to protecting them. And that brings us to the most important distinction of all: the difference between knowing and exploiting. As the demand for resources grows, the pressure to begin deep-sea mining intensifies. But a map is not an invitation to drill. It's a tool for understanding. Exploration gives us the wisdom to make choices, to decide what is precious enough to be left untouched. It's the knowledge that allows us to draw a line, not for ownership, but for preservation. The same technology that can identify a mineral deposit can also reveal a nursery for a species we've never seen before. The choice of what we do with that knowledge rests with us. An albatross just swept through the deck lights, a fleeting shadow against the dock. It's a reminder that we're just visitors here. Every click of the keyboard, every ping of the sonar is an act of translation, turning the silent, unseen world below into something we can comprehend. It raises a final, open question as we stare out at the horizon, where the screen dissolves into the endless black of the water. What do we truly choose to see when we look into the deep, and why? The sun is just beginning to break the horizon, casting a soft, golden light over a sea that's as calm as glass. Our vessel is quiet, just idling here in the vast blue. This is it, the end of our journey together. But also, in a way, the beginning of something new. For 10 episodes, we've sailed across the surface, sending questions down into the deep and listening for the answers that echo back. We've learned that the seafloor isn't just rock and sediment. It's a living archive, a mirror reflecting our own history and our planet's long, slow story. These maps we create, they aren't deeds of ownership. They are promises to look, to listen, and to understand. Each ping from the sonar that we VA sent into the abyss has been more than just a sound wave. It's been an expression of human curiosity, and every contour line that appears on our screens, every newly revealed ridge or canyon, is a story unfolding, a story that's never fully told, but revealed just enough to keep us leaning in, hungry for the next chapter. It's a profound lesson in patience, in the quiet art of listening to a world that speaks in a language far older than our own. It teaches us humility, reminding us that we are just small observers in a grand, ongoing narrative. And with that humility comes a great responsibility. We've talked about the technology, the discoveries, but what truly matters is how we use this knowledge. This isn't a treasure hunt or a race to claim what lies beneath. This is about stewardship. It's about using our maps to protect fragile ecosystems we didn't even know existed, to model the risks of tsunamis and underwater landslides to keep coastal communities safe, and to understand the deep ocean's role in our changing climate. It's about a future of exploration that chooses preservation over possession, understanding over exploitation, a quiet future where our primary goal is to listen and to safeguard. Now, I want you to close your eyes for a moment. Imagine you're standing here on the deck with me. If you could point our instruments anywhere, where would you choose? Would it be a colossal underwater mountain, a seamount teeming with life, or maybe a deep, mysterious trench where the pressure is immense and the secrets are even greater? Perhaps you'd search for the ghosts of an ancient river, its channels still carved into the seabed from a time when the oceans were lower. What story are you hoping to find there? What question would you ask the deep? The beauty of this work is that there are a million right answers, a million new places to illuminate. As our screens begin to dim and the first birds of the morning start to sing, blending with the gentle hush of the waves, we hear it. One final, fading sonar ping, echoing into silence. It's followed by something even more profound, the distant, haunting call of a whale, a true voice of the deep. It's time. Our ship is turning for home, but the questions remain, hanging in the salt-laced air, waiting for our return. If this journey into the unknown has stirred something in you, if it sparked your own curiosity, then please give this video a like, and I'd love to hear your thoughts in the comments. Tell me, which undersea mystery would you choose to map first, and why? Your answers are part of this ongoing conversation, and if you want to join us on more quiet expeditions like this, be sure to subscribe to the channel. Thank you for sailing with us. The ocean is waiting.